We just saw that a point charge can create an electrical field which is spherically symmetrical, radially outward and all of that, right? So now what if we have many charges? What to do? Electrical field due to many charges is a mix and match of all the individual electrical field, like how we study in superposition theorem. Here too we are making use of superposition theorem. To figure out the total electrical field at a point, you have to add up all the little electrical field from each charge by adding them. How? Adding vectorially, vector addition. So again, we're going to make use of principle of superposition of electrical field. So official definition is the electrical field at a point due to system of charges is the vector sum. Here the keyword is vector sum. If you guys miss this word, then it's wrong. Vector sum of electrical fields produced by the individual charges at that point, considering each charge independently. So this statement, I hope you guys remember. All it's telling is if I have a charge, if this is a point of discussion, if there is one more charge, the field because of first charge will not be affected by the field because of the second charge. The absence or the presence of this charge will not affect E1, this being Q1 and this being Q2. So this guy will not influence how this will create a field around it. Of course, the net field, again remember, the net field will depend on both, right? Okay. So let me put up a diagram. Let me take a second. Okay. So yeah. So we'll start off with two charges. So this we're going to call it as Q1. Just a second. It will take a second for the software to, yeah, now it started. Q2. And say this is the point under consideration P. Remember, we are trying to understand how the charges alter the space. So we're not considering anything over here. Now, so we are looking at position vector and all of that. Just a second. Again, it will take some time. So this is your position vector. That's your position vector again. That's your displacement vector. That's your displacement vector. This is your position vector. Again, in vector form, how to write? That's what we are looking at. All this is your this will get corrected in a day or two, guys. Okay. So we have this to be the position vector, and this is your displacement vector. So this is to and from. I mean, that's the convention that I am maintaining. It's kind of confusing. Again, this can be anything. Some might have other way around. Say I have this. So this is the direction of the electrical field because of 1 on P, and that would be the electrical field because of 2 on P because of 2, right? And the vector sum of this will give us the resulting direction. Somewhere along here will be your resulting electrical field at point P. That's it, as simple as that. Again, it's the same funda, just that we are seeing it again and again. So first thing first, we're going to look at by Coulomb's law. The force at P would be, provided we keep a charge of Q naught, it would be what? It will be K Q1 Q naught by R RP1 square into RP1 cap. plus K Q2 Q0 by RP2 square RP2. Next, the electrical field at P would be EP is equal to K Q1 by RP1 square RP1 plus K Q2 RP2 square RP2. As simple as that, right? It's the same thing again and again, I know, but well, it's easy for you guys, right? Enjoy it. Now, in terms of position vector, same pattern. There's nothing else. So KQ1 by this is nothing but RP minus R1, the magnitude square. And the unit vector we need to write in terms of the vector divided by its magnitude, right? I hope you guys remember how to find the unit vector. Plus now the second term Q2 by RP minus R2 the whole square, the magnitude in terms of magnitude, that is. Then to find the unit vector, so the vector divided by its magnitude, right? To find a vector, we can actually, let me do it the other way around. To find the unit vector, we'll take up the vector and divide by its magnitude, right? And that's what we have done over here. Agree, guys? So that's only for your understanding. This you guys need not write in your exam. Right? And your position vector RP, this is RP by the way, R1, RP minus R1, RP minus R1 will give you RP1. Agree? Right? And that's it. You can copy this now.